Alrighty, so today we're going to be doing the opposite of what we did last lesson, and instead of looking for the nth term, we're going to say, what if we know what the term's value is, but we don't know what number it is? So for example, we could look at a sequence like 4, 12, 36, ... some number of other terms, and then 78,732, right? So these are all in the same sequence, and the question is, what number is this? This is T3. Well, what's this number? We don't know. What number is this sequence? Well, we can quickly try and work it out by just doing a little bit of working out for ourselves. So we know that T1 is equal to 4. We know that R is equal to 12 over 4, which is 3. Double check. R is also equal to 36 over 12, which is also 3. So the common ratio is definitely 3. And we know that at some point the term number gets to 78,732. What we don't know is n. We don't know what number that happens. So let's substitute what we know into the formula. We have Tn equals T1 r to the n minus 1. Tn is equal to the first term, 4 times 3 to the power of n minus 1. And we know that the nth term, Tn, at some point is 78,732. And now we run into a problem, which is we can't solve for n in a power. We can solve for pretty much everything else, but we cannot solve for n as a power. So this is a problem. So we can't solve it algebraically, so we have to go to the next best thing, which is guess and check. And in particular, we're going to guess and check values of n. So we're going to work this side out for different n values until we get to the right one. So for example, we could look at n equals 10. Let's see what that looks like. Well, we would get 4 times, well, this would be T10 is equal to 4 times 3 to the power of 10 minus 1, which is equal to, genuinely cannot believe it, but I literally got this on the first try. So I literally just guessed, and I was just lucky enough to find it on the first try. In practice, well, you need to do a few guesses. So you might have, previously to this, if, I wasn't just so lucky, maybe try n equals 5, n equals, 13, and you slowly work your way inwards. In terms of working out, you need to make sure that you specify that using the guess and check method, otherwise you cannot be given credit for it. So really important that you do actually specify that using guess and check, but you can see that therefore 78,732 is the 10th number in the sequence. Let's look at a second sequence. Alrighty, so let's look at this sequence. 20,155,392, 3,359,232, 559,872, and then at some point 2. 2 is in this sequence somewhere. Question is, what number is it? Is it the 10th term? Is it the 5th term? How are we going to work it out? Well, we know that T1 is equal to 20,155,392. That's given to us. And the common ratio is going to be the division of each of these terms. So it's 3,359,232 over 20,155,392. And if we pop that in our calculator, we get a sixth. And just to double check, we'll divide the next two. So 559,872 over 3,359,232. And indeed we get a sixth. So the common ratio is a sixth, and we know that at some point it reaches 2 as a term number. So that means at some point Tn is equal to 2, and we're looking for when that is. So Tn is equal to T1 r to the n minus 1 Tn is equal to 20,155,392 times the common ratio of a sixth to the power of n minus 1. And we're going to be solving for it. So let's sub in Tn is equal to 2. We get 2 on the left-hand side. 20,155,392 times a sixth to the n minus 1. Once again, the variable is in a power. We can't solve for that. And so instead, we use the guess and check method. Now I'm going to try to be worse at the guess and check method this time so I can show you how it works in practice. For example, the first term I might try is n is equal to 5. Well, this would mean that T5 is what we're getting, which is 20,155,392 times a sixth to the 5 minus 1, which is equal to 2,592, which is too big, meaning we need to increase n. So let's try n equals 10. That gives us T10 is equal to 20,155,392 times a sixth to the power of 10 minus 1. Oh, sorry, I didn't include the minus 1. Sorry, this one should have been 15,552. This second one, oh, okay. I'm just too good at guessing. It's 2. If I'd gotten something too small, then I would have continued going. But there you go. So, therefore, the 10th term of the sequence is 2. And there we go. So, there's just a little bit of practice in terms of using this guess and check method to figure out the term number of given terms. Alrighty, I'll see you in the next one. Goodbye.